Yo, what up? Pagan here with the Week 16 devlog for Sonic Entropy. This week, we're continuing our Better Than Blender series and talking about how we're giving Cyclone a better undo system than Blender, and why we had to rewrite how C++ works to achieve it. Blender is limited to only 256 undo steps because it uses something called global undo. Basically, every time you make a change to your scene, a copy of the entire file is saved to RAM so that hitting the undo key can perfectly revert to a previous version. This makes Blender's undo system rock solid, but for complex scenes, you'd end up using a lot of RAM to save all these copies, which is why it needs to be limited. We don't want Cyclone to have a limit on the number of undo steps, so if we don't want to blow up RAM usage for complex levels, we need our undo history to be much more efficient. And right now, it is. Cyclone's undo history only saves the changes that were actually made, rather than saving a copy of everything. So if you modified 5 entities in a single step, it only saves copies of those 5 entities. Right now, this works great. We tested things out with 16,000 undo steps, and it only used about 4 GB of RAM. That's a lot less than an average Google Chrome session. But this is only good enough for now, because currently the entities in Cyclone are very simple. As part of our Better Than Blender theory, we're going to be introducing something called the landmark system, which will automate the placement of objects and creation of meshes based on some user-defined constraints. To make this system work, we'll need to store a bunch of lists that describe these constraints and dependencies to automate everything. And to maximize performance, we'll need these lists to be stored with every single entity, even if the lists end up being empty and unused. But what's the big deal? If a list is empty, it won't take up any memory, right? Wrong. C++ provides a special type of high-performance list called a stud vector. Because a vector stores its data inside the heap, we need to track where the data is stored, the number of elements in the list, and the current maximum capacity of the list. The data pointer, size, and capacity are all 8 bytes each, which means each vector stores an extra 24 bytes even if it's empty. That's an extra 24 bytes per list, per entity, per undo step, which will absolutely add up over time. Our solution? Write our own version of the stud vector, which takes up less space. The reason the size and capacity are 8 bytes each is because you could theoretically store up to 18 quintillion elements in a vector, but we absolutely do not need lists that big. If we limit the maximum size of our vector replacement to only 4 billion elements, we can store the size and capacity using smaller 4-byte variables. With the 8-byte data pointer, this gives us a total of 16 bytes per list, which is a whole 8 bytes better than the stud vector. So yeah, this week I coded a replacement from scratch in 1,000 lines of code, and we're calling it the lib-entropy array. And when I say I wrote this from scratch, I genuinely mean it. If you've ever actually looked at the code for stud vector, you'll quickly see why it would be much easier to write a new one from scratch instead of trying to rewrite 4,000 lines of 30-year-old code. We've still got some tests to run to make sure it works 100% correctly, but so far it looks like it's working perfectly, and for our use cases with the landmark system, it might actually be slightly faster. Outside of the landmark system, we'll still be using the stud vector for other stuff, but when memory matters most, those 8-byte savings will make a world of difference. And that's it for this week. We'll be continuing our Better Than Blender series for the next few weeks, discussing more improvements we're making to C++ with lib-entropy and how our new landmark system works. So make sure you like and subscribe to stay up to date on our progress, and please hit that bell if you want to get notified for new uploads, because YouTube is going to be removing the subscriptions tab soon. Thanks for watching, and we'll be back with more news next week.